All right, let's get started. Well, welcome everyone to the first training session. We're here to talk about best practices for collators, and we have a nice top 10 list to start it off. So let's just introduce ourselves first. I'm Art Kaseman, and some of you probably recognize me from the Discord chat. I'm based out of New York City. I've been here paying too much for rent ever since the .com era, where I got my start in technology. I got into crypto around, I want to say 2015 during this altcoin expansion with a nice home-built mining rig. And I quickly realized that, all the profits were going to the electric company. So I sort of wound that down a little bit. And I actually joined PureStake about 2 years ago. And I started out in our substrate validation services, running Kusama nodes, Polkadot nodes, and nodes for some other customers and some other blockchains. And now I'm supporting Moonbeam, among those other things. And from running our own nodes to coordinate with our collator community. And I'm joined here today with my colleague, Gil.
Yeah, hi guys, I'm Gil. I'm based in Lisbon, Portugal. I'm sure that most of you have spoken to me at some point in Discord. I've been helping new collators get on board, especially in Moonbase Alpha network. I've joined PureStake around 6 months ago, and it's been my first serious contact with this blockchain world. But it's pretty amazing, especially seeing a network get created and all the moving parts that are required. Yeah, Art will now give you some housekeeping rules for this call and also a brief introduction. Then we can jump right into the best practices.
All right, first let's go over a little housekeeping. So we're going to go through about 40 minutes of presentation and demos, followed by about 20 minutes of Q&A. So if you have any questions, just post them in the chat as we go along, and we'll stop from time to time to answer them. So when we started PureStake, before we decided to launch Moonbeam, we were really focused on the validation services for a few different networks. So I've experienced firsthand in setting up validation services for any number of these people. So we got to start with Algorand. Soon after that, we added Kusama. Actually, it was Alexander at the time. But Kusama, Polkadot, and also Centrifuge, along with some bridges and RPC nodes and things like that. And we set up all that infrastructure mainly as VMs, using Terraform and Ansible. And now that we're launching Moonbeam, we've built out of actually fairly sizable infrastructure on that based on Kubernetes. So we do have some good experience in the industry that we'd like to share with you guys to pass that on. So the goal of this presentation is to use our experience really to help new collators join our growing pool and offer some best practices to follow. So some of this may be somewhat basic, but hopefully there's some details even for the most experienced operators. So I just want to say, collators are an important part of the community. And, as Derek mentioned in the last AMA, we believe like a strong, diversified collator community is important for running a successful network. While collators don't actually produce blocks, it doesn't mean they don't have an important role to play. So things like miner extracted value, which is basically front-running transactions, is a huge problem on Ethereum. Overall censorship of transactions, either personal gain or government censorship, can and it probably will happen in the future, especially when there's a centralized set of collators. It makes it very easy for this to happen. So having a diverse set of collators is very important to combat all these issues. All right, well, let's get started here on the best practices. So starting off the top of the list is really just knowing the difference between Moonbeam and other substrate-based networks and parachains. So on the subject of accounts, we decided early on in the development process to add full support for Ethereum-style H160 accounts, which we use for almost all functions, with the one exception being the session key that you guys use for collating. So this means there's no mapping between a substrate account and an Ethereum account for EVM functionality, which is basically different from all the other parachains out there, especially all the ones that support EVM functionality. So you use your Ethereum accounts for everything, the EVM, the staking, the governance functions, and you don't use substrate accounts. So as mentioned, you really only use substrate accounts once, and that's when the session keys, and you really just map that, once or maybe once a year or something like that to prove its identity. So one other thing to note about parachains is that they have less time to fit everything into a block. So currently the allocated time is only half a second for compiling the block and getting the transactions into a proof for the validator. The rest of the 11.5 seconds is spent sending the block to the validator, having it validated, and gossiping that block around. So this will improve in the future. We are moving to a 6-second block time, and that, it doesn't seem like it, but it actually gives us more time to compute the block. But for now, this really affects things like block gas limits, and it's really how much you can fit into a block per block. So what happens is if there's too many transactions in a block, you can't compute it in time, and then it'll fail that block, and it'll try it again and again and again. You actually end up stalling the chain. So it's also the reason we recommend the fastest CPU you can find. That's like the per clock speed. A collator with a slower CPU may not be able to fill the block in time and not produce the block, and it would end up not skipping the block, but you would delay the network by 12 seconds. So to keep computation time down, we opted for a simpler block production and collator selection method compared to Polkadot. So there's just no way that we could fit fragment, that huge thing that they have to select validators. There's just no way to get that into a half a second. It's not even close. So what we did is we have nominators directly nominate collators, and then they can specify exactly how much they want to nominate each one by. So there's really no computation there. It's all set in the beginning, and then it's just read from the chain state. We do have bonding requirements, but there is no slashing, right? So it's really just to prevent a denial of service by flooding the candidate pool with like millions of candidates, and then that would just take too much time to compute, and it would stall the chain. So there is the requirement just to submit that transaction, but it's not held to be slashed in the future. So that being said, we may change this in the future if there's a lot of bad behavior. But for right now, you get rewards when you're producing a block, and you don't get a penalty for not producing it, right? But on the flip side, a lot of nominators, won't look kindly on that, right? So if you're not producing blocks, they may not want to nominate you anymore. I mean, they probably won't. So, and that's especially true for the foundation, because the foundation is really interested in fostering like a fast, performant network. And if collators are skipping a lot of blocks, that's not going to happen. So they would very likely stop nominating people who are not producing their share of blocks. And one minor thing, there's no concept of a controller account. Those were pretty much legacy anyway on the Polkadot network. They were really just put in there until they finished their proxy palette. So we just opted to skip over that, and we just use proxies, which we'll discuss later for sure. It's one of the slides. So again, just to remind you, if you have any questions, just post them in chat, and I'll probably get to them in a couple slides. All right, keeping your account secure. So this is a pretty big one. So due to Moonbeam's sort of EVM compatibility, and it's really the whole reason to be, you can select any number of tools to generate your Ethereum style keys, right? I mean, there's tons of them on the network, right? There's hardware wallets, there's browser add-ons, and like just a ton of different Ethereum-based wallets out there. But I gotta say, like a lot of them are not secure. So we really got to be careful here on what we use to generate our accounts. So maybe for a quick account for development purposes, it's totally fine. I wouldn't bother doing very much. But if you have like a lot more money on there, or if you're trying to secure a production network, I'm gonna strongly recommend you generate the keys in a more secure fashion, which we'll talk about. So the three main areas you need to consider when generating and using these keys is the tool I'm using trustworthy, right? And is the machine I'm running it on, is it safe? Is it hacked? And also, is the backup method secure, right? Because you can get your keys compromised in any of those three areas. So first, let's talk about generating a key. So what tool can you trust? So as I mentioned before, there's a lot of ways to generate an account, but a lot of people don't know you can use the Moonbeam binary itself. And I would argue this is actually probably the safest thing to do. There's a vested interest by the Moonbeam team to offer a secure way to generate keys. And if we didn't, the network would likely fail. So, if you're running Moonbeam, it's pretty much, you're implying that you trust us anyway. So it's probably a good thing to do. So in addition, it's actually the only binary you can use to generate both Ethereum style and substrate style accounts. So I'll show you that in a second. You can see from the screenshot right here how that's done. But I'll go into that in the demo as well. So next, how are you going to generate these securely? So a little reminder, I am talking about production keys or ones with a significant amount of funds, right? If you have $100 on an account, it's probably overkill. But that being said, when you do this, I recommend generating more keys than you need. The process takes a little bit of time, so you just probably want to queue up a bunch in advance. Then you can just pluck them out of cold storage when you need them later. Because if you're in a hurry, you're trying to sort of knock something out, you're not going to want to go through this whole process as a one-off. So it's better to do it in advance, and even better to do it and not need them than not have them. So here's what you're going to need. You're going to need a Linux live CD or USB, I guess, with the Moonbeam binary on it. a laptop, and your preferred backup method, right? And once you get everything together, the steps are pretty straightforward. You're going to boot the laptop from the Linux Live USB. Then you're going to disable the Wi-Fi and Bluetooth and disconnect the network cable if you have that connected. And then you're going to load up that Moonbeam binary from the USB, not the network. I mean, it's very important, basically, that you keep the network disconnected for this entire process. You're going to use that Moonbeam binary to generate all the accounts you need, and plus a few extra, like I said. And finally, you're going to back them up using the secure method, which I'll go into next. So how are you going to back these keys up? Well, there are many methods, and you really just need to pick one that fits your risk profile, right? So the name of the game here is to ensure that the keys are both secure from theft and recoverable when needed, right? So I'm going to caution you here not to go overboard. You got to keep within reason, right? You can make backups so secure, they end up locking yourself out forever. And actually, a little anecdote here. As I mentioned, I got into this sort of Bitcoin mining, the altcoin mining back in the day, maybe 2015. And it's right around when this coin called Dogecoin launched. So I had coins at launch. No one was even mining the thing. And if you look all the way back at the chart, there's this little like rise in price. You can't even see it now because it's basically flatlined with the current growth. I sold some of it, but then it basically went to zero worth for a long time, for maybe 5 more years, until Elon Musk started posting about it. The problem is I had the wallet encrypted, and 5 years of not even thinking about it, I completely forgot what the password is. So I actually have a Dogecoin wallet on my machine, carefully backed up over the years, but I have no idea how to get into it. And I don't even know if I have $1 million in there or zero. So again, a word of caution, don't go overboard here, but keep it within reason. So a couple examples how to do this, I guess, from least to most secure. At the very least, you're going to want to write it down, right? You can do it with a piece of paper. You can hook up a non-network printer to the machine you use to generate the keys and just print it there. As long as it's not going over the network, you're not connected to the network, it's okay. Then you're probably going to want to laminate that with just a laminator you can buy on Amazon, pretty cheap. And what that will do is protect you from water damage. It's pretty easy to get a piece of paper wet and then make it illegible. So the next level up would be to use a metal plate, either to stamp the mnemonic or maybe even scratch it in there. Or you can buy a pre-made one from Amazon, which will protect from both water and fire damage. And the next level up would be to shard the keys first, and then back up each shard securely. So a popular tool for this is called Horcrux, which is sort of aptly named after the Harry Potter series. What this does is it splits your key into multiple shards, and then you can combine a configurable number of them to reconstitute the key, right? So for example, if you decide on a threshold of 3 of 5, then you'll have 5 shards out there somewhere, and you can recombine any 3 of them into the key without having access to the other 2. So the shards should really just be spread around. It should be kept in different places, like a safe deposit box, like a trusted friend. The key is you don't want someone to find 3 of them, and you want to remember where they are. So again, if you lose access to all of them, you're not going to be in it for a good time. So I did leave out one option, which I'll discuss briefly, and that's hardware wallets. So first of all, they're not yet officially supported for staking, so you can't use them anyway. You can use them for EVM functions. We'll probably add support for this in the future, but for right now, they're not. You can't use them. So they are convenient and secure, but really they have one major flaw, like their Achilles heel, and that's the fact that all the accounts are derived from one key, right? So, and because you don't want to lose, or there is risk of loss or theft of the device, so you got to back that key up anyway, right? So you have one key you need to back up, and then every single account you use is derived from that key. So if anyone ever gets that key, you lose not only that account, you lose every single account you had on that ledger. You can lose all of your funds. So it's because of that, I really don't recommend it for, very large sums of money or, important production networks like this. Okay, proxy counts. So proxy counts are very important for account security. So they allow you to have a key online and ready to go when needed, but they don't sacrifice the security of the underlying account, right? So this means you can perform all the staking functions you need to perform, maybe in the middle of the night when you wake up with a page. But the primary account is always, safely tucked away in cold storage. So, I guess you guys probably know, any hacker these days, after they compromise a machine, they're going to start looking for crypto keys, probably automatically, right? If they find any, they're just going to drain the accounts. It might be all scripted. It'll be gone before you know it. So a proxy account will only have really like a couple a couple dollars on there for transaction fees, and the loss would be pretty much insignificant, right? They could take this key and sort of grief you and like try and take your collator offline or something like that. But honestly, they're after money, and they probably wouldn't even bother to do that. So if and when a proxy account's compromised, or even for ongoing security, you might want to do this, every year or something like that. What you do is you take out the underlying primary account and you revoke the old proxy account and you just add a new one. So anyone who had ever gotten access to that old one doesn't matter anymore because it's not authorized. So how does this work in Moonbeam? So the proxy palette it's pretty much identical to the one in Substrate with the addition of the Ethereum address support. So if you guys have used it in Polkadot, it'll be very familiar, right? You can't use it for the EVM, right? Ethereum doesn't support proxies, so we just don't support it either. You can only use it to do the sort of substrate type functions, right? Which are the staking, the governance, and I think you have one called non-transfer and you have one called any, right? So the first two are pretty self-explanatory. Non-transfer means you can perform any call aside from transferring funds, and any, of course, means you can transfer funds as well. So depending on the organization and how much you trust someone, you can select one of these options and what you need to do, right? So pro tip, you don't use a shared proxy account for the team. I would set up an individual proxy account for every person on the team. That way, pretty much there's accountability, right? So you know who did what and when. And if any one of those keys is compromised, all you have to do is disable that key. Everyone else can continue to do what they need to do. And pro tip number 2, you can actually use the delay function, which you can see at the very bottom of the slide here. And what that does is it adds a block delay to when the transaction is actually applied, right? So you would submit the transaction with your proxy account, and then it would have to wait that number of blocks. And what you can do is you can set up an alarm that will just sort of monitor the chain state. And if this proxy account ever, submits a transaction or ever submits a transfer funds transaction, probably, you can set up an alert to yourself, and then you could look at the transaction. You would have this many blocks to cancel it basically before it goes live, right? So it's a great way if you do want, even for yourself, if you set up an any proxy that can do anything your cold storage account can. If that ever gets compromised, you'll get an alert, and you'll have time to take yours out of cold storage to cancel it. All right, finally, when are you going to use these? Well, I guess in short, you can't use them yet, right? I'm talking about it, but you can't even use them yet. We're still in phase 3, and balance transfers are not enabled, and they're not going to be enabled until phase 4, which is going to be out in a couple weeks. So it's pretty soon. And really, the reason why, I mean, you could set up the proxy, you could even probably authorize it, but the proxy itself wouldn't have any funds, and it can't submit a transaction. So let me go to a quick demo here. And again, if you have any questions, post them in chat, and I'll get to them after this. All right, let me switch up my screen here for a second. Okay, assume you guys can see my console. Let me get a little bit bigger here.
Yes, we can see it.
You can see it? Okay. All right, so the first thing to do, if you're gonna go to all the trouble of going through this key generation ceremony, you're probably gonna even want to compile from source yourself. So to do that, I'll just go over it briefly. I'm not actually gonna compile it, take too long, but you go to the Moonbeam. Assuming you've cloned it, you just do a quick git pull, get the latest, and then you can do a Rust update, and that basically gets the latest version of Rust. I've already done it this morning as I was prepping. As you see, the latest version is actually 8.9, right? Which you'll see in a second. And then there's actually 2 things you can do. You can compile just a tool to generate the keys, which is actually called Moonkey. I didn't talk about it yet. To do that, it'll be a little bit faster. You can say cargo build -p Moonkey, and then release. And as you see, it'll start downloading crates and go through the compilation process. And just one little thing to note, it actually doesn't use the latest Rust. It actually uses a configured Rust. So, but you still need to get the latest Rust to make sure you're at least up to that version. And then to compile the binary, of course, it's cargo build release. And I'll do the same thing. It'll just take a lot longer and use a lot of your CPU. So when it's done, it's going to go into the target release folder, which is here. target, release. As you see, you have your Moonbeam binary as well as your Moon key. So just to go through the Moonbeam one, this Moonbeam key help will give you basically a quick and easy help to see what you're doing. So just talking this through, this first one, generate. This generates a random account. It doesn't specify, but this is actually this is a substrate style account. So this would only be used for like your substrate type things. Generate account key is the main one we're looking for here. This one generates your H160 account, your Ethereum account. And this one I'll just briefly discuss. This one generates your lib P2P key. So if you're doing automation or something like that, and you want to have a deterministic peer ID for this node, so maybe you could reserve them together with automation, you're going to be generating these node keys in advance and put it in your code. So what we're going to do here is Moonbeam key generate. That gives you a quick substrate account. If you want a longer mnemonic, you can say I want 24 words. So it just makes it a little bit more. A lot of the plates you buy on Amazon, they might not support 12. I think they support 12 or 24, but you know, obviously you have 12, you can fit more on the plate. And then for your actual Ethereum account, you just do Moonbeam key generate, I think account key, right? Generate account key. Yep. And of course, this is your public address here. This is your mnemonic, which is actually, this tool is one of the few that actually will give you a mnemonic. And then of course the private key and the derivation path. So in short, you have your mnemonic plus your derivation path will actually give you this private key. So you got to be a little bit careful. Some tools will have a different derivation path. I believe like a ledger device has a different one. So if you try to just plug this in to say a ledger, you're not going to get the same private key. So you gotta, I would probably just store this path with it. If you're storing just the mnemonic, just to, you can always get back to the private key. And let me switch over to show you proxy accounts real quick. This is it. Yep. Okay, so I set this up. There's actually an issue on Moonbase Alpha right now, so I'm not going to actually submit these transactions, but I'll just quickly walk you through them. Let's see. Real quick, we're going to go to your extrinsics. I'm going to get into this a little bit later, but pretty much you go to developer extrinsics here. Then you select your proxy count up top. And then you, when you're going to, say you want to add someone, you do proxy, add proxy. And then you're going to say, oh, I'm sorry, I did this wrong. You're going to start with your collator. And the collator, this is the underlying account. The collator will submit this proxy, add proxy to your proxy account, right? And then this is where you select any non-transfer governance or staking. We'll do staking here, and we'll set the delay to 0. So this would be like your standard setup for a proxy account. You submit this, and then if you want to ever reject it or get rid of it, you just say remove. Well, you have two options: remove all proxies here and remove a single proxy. So we'll say remove a single proxy, and you submit that and get rid of it. And quickly to use it, you would use your proxy account. You would do the proxy command right here, and here you would select your collator, which is the one you're actually going to be using, and then you do any one of your sort of proxy commands like bond more, bond less, go offline, that kind of stuff. So I think we're getting a little late here, so I'm gonna wrap it up here. I guess why don't we stop briefly for questions? I know I did ramble on a little bit there, so if there's any questions, I can answer them now, or we can move on. Kathy, are there any questions?
Yeah, we have some questions here in the chat.
Okay.
I think one is like it's coming up on the presentation, so I'm gonna not say that one, but we have, is it providing the same key generating function? I think this one is referring to the monkey binary generated during compiling. I know that you're gonna talk about this later in the slide, so I don't know if you wanna give a small answer to this.
I'm sorry, can you repeat it? I didn't get that.
It says there is also monkey binary generated during compiling. Is it providing the same key generating function?
I'm not sure.
The monkey versus the monkey versus the
It's a
Moonbeam
question.
key.
Yeah. It's a question by Mark Bonn.
Yeah, it's my question actually, but I think it was answered. I was just wondering whether the Moonbeam key generating function and the Moon key generating function is actually the same functionality of key generation.
Yes, good question. It is. I wanted to show that, but I think I was going too late, so I didn't show it. It's exactly the same. You can prove that by getting a mnemonic, and you can import that mnemonic into Moonkey, and you'll get the same account generated. It uses the same derivation path, so you can use either one.
Thank you.
Yep. I know we are running a little late. Jill, do you want to pick it up, and we can get any questions in a little later?
Yeah, sure. So knowing how to install and configure properly. My goal here isn't to explain the steps required to install a node. We have some good documentation available for that, and I'm sure it's safe to say that most of you have at some point gone through it. But instead, I want to give you some good practices for this process. So keep in mind the requirements of running your nodes. You don't want to under provision or over provision, especially in your production environment. In development, sure, you can save some money there, but in production, the node will end up taking the resources when you least expect it. So this also doesn't mean that you can just give your node 32 cores and let it sit idle. I mean, you can, but it's not the most profitable idea. You need to monitor what's being used, especially during peak load, and you want to leave some room for growth. In Moonbeam's case specifically, some processes are single-threaded. So what you need is fast per-core execution. So you want to focus on your CPU. As Art mentioned before, with the current limitations on parachains, each parachain only has half a second to process the blocks and send them on to the validators. So this doesn't leave a lot of time for slow processors. This is even more apparent in Moonbeam Alpha, where eligibility is not set to 1. And this ends up penalizing slow block producers. We recommend having only one application per virtual machine or container, especially in production environments. If you do end up running multiple applications in just one machine, for example, for testing, you need to make sure that there are no conflicts with your ports. So this is a common mistake that we see. Art can, yeah, thank you. You can easily change your ports with these flags here in the slides. And when in doubt, you should use tools such as netstat, which let you show what application is running or listening on each port and make sure that there are no conflicts. Upgrading on time. You should monitor the Discord chat to know what's coming. Some releases will impact your ability to produce blocks unless you upgrade, or cause other issues that might cause you to lose sync. You can, it's a good idea to automate the monitoring of new releases, and I'll talk about this later, but being active on Discord and to the pings in the Collators channel is critical. We have good documentation available on running a node, and there's a lot of information now to improve your Collators performance, but you have to keep in mind that as we update our network, we are also updating the documentation. We usually let you know through announcements in the Discord channel that you have to do some changes, but a mistake that we've seen in the past is people using old flags or configuration. So it's a good idea to check every now and then and make sure that there's no changes, especially if you are having issues. And if you are having issues, a good skill to have is knowing how to share your logs. We can't help you if you don't provide good information on the errors you're seeing. So the best way to do this is through good logs. The process of obtaining them is different from setup to setup, but I've put on slides some of the commands that you can usually use for Docker and systemd, including some useful flags that will usually ask you to provide us, such as setting a time range for the logs. Before I move on to the next section, is there any questions related to this part? Okay, I think no, so I'll just move on. If you have questions, feel free to put them in chat. Infrastructure as a code and automation in general are very useful tools to have when it comes to being a collator. Managing a collator's node lifecycle entirely via code and automation helps you be prepared for any issues that arise to scale up or down. Or on top of all that, also gives you reusability. So you can apply your code and experience to other projects. If you have, for example, set up your Moon-based alpha node using infrastructure as code and automation tools, setting up your Moonriver node should be as easy as just changing some variables. Even beyond that, you can use this in other Substrate projects. I'll be talking about and showing you some of the tools that we've used. I don't want to do an in-depth discussion on what are the best tools, and I'm sure everyone will have their own opinion on that. But the main thing that I want here is that to give you the idea that if you are not using infrastructure as a code, please consider it. So one of the automation stacks that we've used, and Art talked more mention it, is Terraform, Ansible, and Jinja templates. We use Terraform to stand up our cloud provider instances, so put our nodes there, and then use Ansible alongside the Jinja templates to stand up the applications in these instances. So I have a small example here on the slides of what's possible with these tools. This is a systemd on the left, systemd service file that you might be familiar with for setting up a Moonriver or Moon-based alpha node, for example. But we have turned it into a Jinja template by injecting some variables that we might want to change between deployments or projects. Then we use the Ansible code on the right to fill those values up and set up the node. So this is just a small example of what's possible. Another useful thing I've sort of mentioned before is automating the monitoring the new builds. For example, one of GitHub's functionalities is the ability to watch for new releases, or you could even make a script that alerts you of these releases on your platform of choice. This shouldn't replace the paying attention to the Collators channel in Discord, of course, but it's a good way to know that these changes are coming and to be ready for them. Then leveraging infrastructure as a service, infrastructure as code. Sorry, you could have those builds ready for deploying as soon as you press a button. This is just a small subset of things that can be done, and this is a topic that we could talk about for hours, I'm sure. But if I just wanted to give you a brief introduction. If there are no questions, I think you can go ahead.
Okay.
We got a question here if the collator size will increase on phase 4.
We don't know. I mean, I don't think so, but we really don't know what the demand is going to be. So it's sort of a wait and see kind of thing. I would say from the recommended, no, but from the current usage, it may go up, if that makes sense.
Okay, perfect. And then another question from Peter from Collators is, can the Moonbeam team share their automation scripts? Is that something we can do?
Yeah, we were talking internally about doing this, and I think everyone's on board. It's just we've been so busy, we haven't been able to, sanitize it and put it into a repo for you guys. But we are planning on doing that, so we'll be posting that in the future. I'm just not sure exactly when. Awesome. Thank you, guys. Okay, cool. Let's move on. All right, chain state. So chain state is actually pretty important. So what it does is it stores the data variable and really the state of the chain. It takes all the transactions into effect, like up to that block, right? So for example, like other balances, right? Everyone can, in each block, people can send balance transfers to each other. And if you didn't have the chain state, you would have to sort of go for block one and sort of compute them all every single time, right? So that it just doesn't work. It just doesn't scale well at all, right? So what it does is, like, in each block, there's a state transition function, and it basically takes, all the transactions that happen, and sort of applies them to the current state, right? So you always know the current balance of all the accounts, for example, among other things. For collators and nominators, there's a couple of things you might want to check. Really, a lot of the stuff that we here, actually, we just look at the slide here. Yeah, a lot of stuff we talk about. Just looking at my slide here, the example, this author filter eligibility ratio, that's actually the eligibility ratio for everybody. So right now it's set to 1%. There's a ceiling there, so it just picks, it goes up to the nearest one. So right now this means the eligibility is set to 1, but previously, or even sometimes for an upgrade, we may increase this temporarily just to make sure. But you don't have to ask, you can just go look. Same thing with the next one here. The parachain staking total selected. This means basically how many people are selected to be in the pool, like how big is the pool, right? Right now, we just increased it with democracy to 40, so that's where it's at right now. Going down, you have this parachain staking collator state 2. This is more used for nominations because you need to know how many nominators are nominating a collator, and you also need to know how many collators have I already nominated. So, you know, I don't want to get into too much, but basically, there's a the Polkadot.js site is not completely finished yet. We will have like a staking sort of section in there, like you see in Kusama, but for now there isn't. So you're going to have to go into the chain state here to get these answers. Over on the top right, we have parachain staking selected candidates, and that's basically everyone who is selected for the current round, right? So the way it's selected is the top. It's basically it's very similar to Kusama, but basically it's the top collators by nominations, you know, including their own bond, get selected into the pool. And then once they're in there, it's pretty even. I'll talk about that in a little bit. But if you want to know, hey, am I in the pool or was I selected for the next round or something, this is where you would look. The final one is everybody in the pool and how much they have, how much stake they have behind them. You need to know this for, I believe, to become a collator, you need to at least count them. And I think Gil's probably going to go over this later in a little more detail on how to script it, but this is where it's actually coming from. So this is all of the candidates. So those are just like some example of what you can find in there. So I mean, that's pretty much it for chain state. It really ties into the next slide, which is extrinsics, right? So it really goes hand in hand. So as I mentioned before, the Polkadot.js limits like what you can do with it, right? So you're really going to be needing this for the next few weeks to a month, right? One interesting feature about Moonbeam itself is because of our EVM compatibility and the fact that we support these H160 accounts natively. We can actually use DApps and even maybe smart contracts in the future to perform staking functions for us and nomination functions. So we are looking at that. We're developing it now. I think in a couple of weeks there will be a DApp to use for staking, but honestly, you know, I recommend you guys understand it and know how to use both the chain state and these extrinsics to do it yourself now. In fact, it's in the docs, so you really just need to follow along. But there's a lot more interesting stuff in here. So yeah, as I mentioned before, I'm going to show you some sort of manual things to do, and Gil's going to go through a little more of the automated fashion. So another good reason to dig into these extrinsics is it's pretty simple. So you just need to know what you're signing, right? So a lot of DApps, especially maybe the crowd-loan ones that you just used maybe a few weeks ago, really they're just websites on the internet, and you need to sort of implicitly trust them unless you read what exactly it is you're signing, right? So basically, if you just sort of, I know a lot of people have done this. I mean, don't get me wrong. A lot of people just go in there, they fill their information, they click sign, it pops up a little window from Polkadot.js to sign it, and they just click sign, right? Honestly, you do that, you're a little bit at risk, right? Like it could say one thing, right? So it could say on the website, the text of the website could say, you know, hey, you know, submit 100 KSM or whatever to our crowd loan, right? And then when you click OK, yeah, let's do that, it'll pop up something that just says, send me 100 of your KSM instead, right? So really, unless you sort of expand it and dig in there and know what it's doing, you know, you could just be signing something you really don't want to, right? So it's really pretty much like signing a contract someone gives you in real life without reading it. It's very similar. So knowing these extrinsics really could save you from you know, getting rugged or something like that, right? So we're getting a little late. I was going to do a quick demo, but I think I may skip it and just so we can have more time for questions. So again, any questions, let me know. I can answer them now, or we can answer some in the end.
I don't think we have more questions.
Okay.
Yeah,
great.
I'm actually.
Or yes, we do.
Go ahead.
I'm actually wondering whether it will be possible when the transfers are enabled for people to nominate to Moonriver.
Yes, it is, but
Yes. Sorry, to clarify, of course it's possible, but I mean, is it possible then with Polka.js? Because currently there's not such a function, you said.
Oh, yes. Okay. So I would say at launch, this is our current plan. At launch, we probably will not have Polka.js working with like a nice user interface for nominating and staking even. But we're going to have a DApp. It's a little bit faster to develop. So we're going that route for launch, and then we're going to follow that up with updates to Polka.js. So there will be some page on the Moonbeam.network website that'll assist you with nominating and collating, right? Because you got to go in there and literally count. It's very non-user friendly. Like you got to go count how many collators have you already nominated and how many nominators has this collator already had, right? These are the things that really speed up the end of session like block time, which we need to keep it under half a second, but they make it very not user friendly, right? So yeah, just to summarize, there'll be a DApp for now for launch, and then there will be followed up with the Polka.js updates.
All right. Another question would be that until this DApp is developed, how would I go away to nominate, to try out nominating with the terminal or with the CLI?
Oh, sure. Okay, let me do a quick demo then real quick. Hold on a sec. It's much easier just to show you. Okay, so you would go into, well, first you got to start with your chain state. Okay, I preloaded a couple of these here just for speed. So for collating, you need to know the candidate pool, right? And then you need to know, you do need to know the collator pool. So you basically have to count all these up, and Jill will show you a faster way to count them. But pretty much you need to go to parachain staking candidate pool and then count them, right? And then for nominating, you need additional information. You need to get parachain staking collator state and nominator state. Unfortunately, my demo nominator didn't have any nominations, so it's shown as 0. So you would enter 0. But for this collator also has no nominators, so it would be 0. But in general, you would have to count how many nominators it has, and you would do the same thing for the nominator. You need to count how many nominations has this nominator already performed. You know what, we'll probably have, if we don't have it already, we should probably have we'll have some documentation on this, but this is what you would do. You go into developer extrinsics, and with that information, we'll just say you're a nominator, right? We'll get rid of the proxy for now. When you go to parachain staking, you would say nominate, right? And then it's who do you want to nominate? And we'll nominate our demo collator for, let's say, 400 mover. Okay, and then these are the two numbers which I just showed you how to get. So the nomination count is, let me make sure I get this right. Yeah, let me start at the top. Collator nominator count is how many nominators are already nominating that collator, right? And going back to the chain state here, you would see that here under nominators. As I mentioned, it's not user friendly at all in any way. This would just be the number, right? Because what you're doing is you're basically inserting it into that specific index number. Like it needs to know how many are there, so it can just insert it. And then the nominator count or nomination count means how many nominators have I already nominated. And unfortunately, I haven't done it yet with this guy, but it would look very similar to this, and it would just list out all the collators you've nominated. You just need to count them up and plug that number in. Again, I think some of the scripts Jill's going to show, like you can modify those slightly to give you this information. It's going to go a long way into making it more user friendly. So I hope that answers your question. Okay, I'll go back to the. No, skip this. Okay, go ahead, Jill. You want to keep going?
So, using the right tools for the job. As mentioned before, Moonbeam as an EVM supports a wide variety of DApps, and there are many other tools out there. I'll be focusing on some of the tools that are useful for collators and nominators. And of course, if you find or even develop a good tool, feel free to share it with us on Discord. We always love to see those kinds of contributions. So block explorers are incredibly helpful to decode what's happening on Shine. It's not just for the smart contract development, also to help you confirm send funds or other staking related transactions. Some of the available block explorers for Moonriver and Moonbase Alpha are Block Scout and Subscan. I'm personally a big fan of Subscan, and I used its taking sectional time to check the collator pool and the waiting list, instead of having to use chain state calls in Polkadot.js, as Art just showed. Speaking of Polkadot.js, and as Art has been talking about, it is very useful. Not yet. I'll let you know.
Okay.
Polkadot.js is very important for staking. You can do it without it, but why would you? As Art mentioned, it's under continuous development, and we are adding some Moonbeam related functionality, but you still need for now to execute extrinsics for staking. Still, it's very useful for that. And something that is very useful and that I was talking about, and it's sometimes overlooked, is the API, the Polkadot.js API. So now I'll share my screen. You can stop that.
Sure. So can you see my screen now? Yeah.
So if you recently had to join the candidate pool following the latest instructions, you probably had to do this step at some point because of the new parameter that Art showed, which is the candidate count. So what we give, because Polkadot.js isn't ready with this taking functionality, what we provide as an easy way to do it is running a script. And this script, you run it in Polkadot.js. You go here to developer and JavaScript, and you can just paste the script and run it. And it will give you the candidate pool size. And basically this parameter is what you put when you are joining the candidate pool. But this is just a small example. I mean, it's very simple. What it does, it calls the candidate pool chain state call, which I showed you. And then instead of having to count it all manually, it just returns the length. This is all very simple, but it's a very powerful tool. If you wanted to, for example, you could automate the entire process of joining the candidate pool, or as we were talking about, even nominating someone using this JavaScript library. Polkadot.js offers some examples here on how to do several things, so it's very helpful. And it also has some documentation, which you can access by going to the main page and clicking here on the documentation. So it explains everything, how to do chain state calls, extrinsics, etc., using the JavaScript API. And yeah, I'll stop sharing for now. You can go ahead, Art, with the slides.
Yep.
And yeah, another useful tool that I'd like to talk about is Gantry. So every collator has set up Gantry telemetry as part of the requirements, but not many of you end up using it to do the full potential. Gantry offers an easy to use Prometheus and Grafana dashboard, which has another bonus, allows us, the Moonbeam team, to view aggregate metrics of your node. So this is great help not just to us, to help keep the network running smoothly, but it also helps you with the free Grafana dashboards for your own metrics. I'll be talking about these metrics on the next topic, but first, are there any questions?
Maybe a similar one, which was asked before by another person. For the ELK stack, could you also provide your script, like for setting up monitoring specifically for Moonbeam?
Yeah, we're definitely interested in sharing scripts and templates for the Grafana dashboard for these metrics, but it's still some work in progress. But we for sure are interested in doing it.
Great.
Hi, I do actually have a question about the gantry information. Do you think there'll be a way of adding multiple endpoints to the gantry so we can both send metrics to your end and then also one of our own endpoints as well?
I'm not sure if that would be a question for the Gantry team. Do you think, Art, if this is possible?
Do you want? I'm not sure I follow. Are you trying to use? You're trying to send your
so the metric. We want to send
metrics to two endpoints.
Yeah, is that a you question or is that the
Yeah, you can do that.
gantry?
Yeah, 'cause, I mean, the metrics, like, so when you launch the service, the metrics are just sort of sitting there on a port on your machine.
Yeah.
So you can scrape that with any number of tools, and it's just still the same information. So Gantry, what Gantry does, it just goes and grabs that data, and
Oh,
then it
okay.
pushes
I'm with
it
you
up.
now. Yeah,
Yeah,
I'm
it pushes
following.
it up. So you
Cool,
just
cool, cool.
use like another exporter at the same time.
Yeah. Okay. Thank you so much.
Mhm.
Yeah, I think you can go for the next slide.
Okay.
So monitoring your KPIs. So the name of the game here is that you want to improve what you monitor. And you need to know how and what to monitor so that you can analyze if you know that 100%. So setting an alarm on some of these metrics is a good idea. If you don't monitor it, you don't know when it breaks. So most of these metrics are high-level indicators of issues. If there's an issue, one of these metrics will be impacted. So you'll know if there's something wrong somewhere. I would say one of the most important metrics is block production. If anything is wrong with your node, you won't be producing blocks, or you won't be producing as many blocks as your peers. We've recently changed eligibility to 1 in Moonriver. So every collator is expected to be producing the same amount of blocks as every other collator. So I actually have an image of a dashboard that we use, which shows the moving average of blocks produced by collator. And we can see that when eligibility changed, the network got fairer, as in every collator started producing around the same number of blocks. But you don't actually need to keep track of every collator to compare to your own. In Gantry, you are easily able to see how many blocks your node has produced. And if you want to make sure that that production is within the expected, you just need to keep in mind that on average, you are expected to produce as many blocks as every other collator. So the percentage of blocks that you produced, as in your total divided by the network total blocks produced in a certain time range, should be equal to 1 over the total collator pool size. So let me just make this easier, give an example. Let's say that there are 10 collators in the pool. Your percentage should be 1 over 10, which is 10%. And Gantry is able to show all of these metrics. Another thing to keep track of is making sure that your collator, or any node for that matter, is following the tip of the chain properly. So this is the dashboard that I'm showing on, you can go on the next slide, sorry. Yeah, on the top left. This is somewhat tricky to do, as your node only knows what it knows. So if it gets cut off from the network, who is to say what the best block is? But you should make sure that you're not stalling completely, or that your best block is stalled while your finalized keeps going up. Block spread is the maximum difference between your 3 block states, best, finalized, and sync target. Typical ranges are around 3 blocks between them. So this is also important for RPC nodes when you're running multiple behind a load balancer. You don't want to be giving different results depending on what node your users are connected to. And finally, block rate, it's related to the block production, but shown as time between blocks. So you want this to be steady at 12 seconds, although current network conditions make this hard to obtain, and any major issues here are most likely attributed to the overall health of the network and not exactly an issue with your node, but still it's a good metric to keep track of. And yeah, if there are any questions, we're running a bit long time. So.
I have one question. Actually, is there a benefit to use Gantry when I'm already running my own Prometheus and instance actually and Grafana?
I would say for you, maybe not so much, but for us, it lets us get an aggregated view of all the metrics in our own dashboard. So that's why we have it as a requirement.
Yeah,
but
yeah,
for
yeah,
you,
sure.
If you have your own metrics and your own, then that's fine as well.
All right.
Yeah, go ahead, Art.
Okay. All right, made it to the last slide. So I think I got a lot of questions about this, so I just want to take some time to explain it. Basically, how does the token economics work, right? So we have an annual 5% inflation, and this is for both Moonbase Alpha and Moonbeam, but it's probably also going to be Moonriver and Moonbeam will be, I believe, the same. So someone, well, I'll post if it's different, but I'm almost positive it's the same. Basically, there's an annual 5% inflation, right? So of that, 1% of that inflation will go to the collators directly, and then an additional 2.5% go to nominators. Okay, and that leaves 1.5%, which goes to the sort of parachain bond reserve, and that what that is just a pool of money, like a treasury, that we can use in perpetuity, basically, to ensure that we get a parachain slot, right? Because we don't know how much it's going to cost after a year, for example. So we're just going to put money in a pool and make sure we're always going to be a parachain. All right. So of the 1% for collators, right, that's going to be split between all the collators in the active pool for that round, right? And similar to Polkadot, the actual payments will be related to how many blocks you produce, right? So the more blocks you produce for that round, the more you get paid. If you don't produce any, you don't get anything, right? So we talked about before, I'm probably going to say it again, that the eligibility setting really affects this, right? And we just saw on that previous slide, you saw everyone converging to a very similar amount, right? And that's what we want, right? So the higher eligibility, it means the more collators will be selected to produce a block. And sort of here's how it works, right? So if you do have more than one collator selected, each one will generate blocks and submit them to the validator, right? So the first block received and validated will earn the reward, right? And the others will then just be discarded. And then we'll receive nothing for that block. So right now we're currently at 1%, right? Which means that each person, or each collator rather, only is selected to produce one block, right, in turn. And if you're able to produce it when it's your turn, you receive, over time, an equal amount of rewards as other collators, right? But if you're not, you're going to see that dipping down, right? And you probably won't see it raising up too much higher than average. Because being a little bit faster is not going to help you here when it's 1%. It would only help you when the eligibility is higher. Right. So it is, again, I want to stress, it's important to have this fast network connection and a fast CPU, right? So you need the network connection. You got to make sure you're in sync, right? If it's your turn and your node is not quite in sync, it's like one block behind, you're not going to have time to produce that block, right? Same thing, you only have like half a second. You got to make sure you get that compute in time and get it sent over to the collator. And honestly, I'm sorry, the validator. And honestly, the validator could actually have a problem as well, right? If that validator, for whatever reason, just isn't able to ingest that block, then you're not going to get paid for it. It's not your fault, but there's just no way to fix that, right? It's out of our control. And there's 900 of them on Kusama, so there's just really no way to track that very easily. Okay, COGS. So COGS stands for cost of goods sold, which some of you probably already know. But in this case, it's the amount of money you spend in order to provide collation services, right? So this is just all the costs you need. Let's say your CPU, your memory, hard drives, all that stuff. And in particular is bandwidth, right? So if you're running in a private cloud, these bandwidth costs, especially the relay chain, is what you're gonna have to look out for, right? Kusama's been around for a while. There's a lot of validators. There's a lot of traffic moving back and forth. So you're going to see this in the hundreds of dollars every month if you're in one of the big clouds, right? And you're paying for each meg that's going out, or each gig that's going out, right? So you really got to keep an eye on this number. So to help you do that, if you are in a public cloud, you can set up tags in each cloud provider, right? It will help you identify which costs are associated with the project, right? You may be running Kusama validators, Polkadot validators, Moonbeam validators, right? You want to sort of know your costs for each one, okay? And then, of course, wrapping it all up, your profit is the revenue minus your COGS, right? And then, as I said, you're going to want to track that per project, right? So you don't want to just be one of the key things we don't know yet is how much Moon River is worth. But if we just take the example of Kusama, you could say, how many KSM am I earning per month? And what's the average price for that month? You can get roughly what your revenue would be, right? So as soon as Moonbeam and Moon River are available on exchanges, we'll actually know the value of it, and then you can sort of make that computation, right? And finally, I'm just going to end with, your time is valuable as well, right? So you got to keep an eye on how much time you spend on each project and make sure it's worth it, right? So you don't want to set it and forget it, right? You definitely need to spend some time on a project, right, to grow the business and to attract nominators. But I would say, to make sure to focus on time to attract other nominators, right? Don't just say, hey, I got this great service here, but don't tell anyone about it. Like, no one will actually be able to find you, right, to nominate you. So again, with the launch of phase 4, the pool is going to open up, and anyone can come in, right? Anyone who participated in the crowd loan, for example, can hop in and nominate whoever they want, right? So there's going to be a lot of money coming in soon. You got to be sure you're ready to capture that, right? because if they nominate someone else or they just pick the first person, you know, you might be out of luck. There could be a lot of money coming in. So you really got to take the time here and put it where you need to do to attract nominators to make sure you're in the pool going forward. I also want to say something like running an indexer, or there's other ways to leverage these cogs, right? Because you're gonna have this kind of, I don't want to say sunk cost, but you have this like recurring cost for the relay bandwidth. And if you know, you could collate one collator on that, and then you know, if you have another collator, you have that exact same cost. But if you want to leverage maybe that cost, you could do something like I would say running an indexer. So there's a lot of indexers on Ethereum that are going to come over to Moonbeam. So they may be looking for indexers to run, right? To index the blockchain, basically the index blockchain and put into a database for faster retrieval. But those indexers get paid as well for that service, and your costs are already there, right? You already have that relay cost bandwidth. You might as well just add on an indexer to that and get an extra revenue stream. So it's something to think about. I'll probably go into that more in the next couple of weeks. That's pretty much it. I mean, we've reached the end of, you know, our presentation here. And if you have any more questions, just post them now, and or just call them out even. We'll answer them.
Guys, if anyone has a question, feel free to unmute yourself, or you can also put the questions on the chat. Okay, it seems we don't have questions. You can also post your questions on the Collators channel in Discord if you have any questions later. And this recording is going to be available on YouTube. I'll share that link shortly with you.
Yep, great. Yeah, if some more helpful information, you know, I'm pretty sure most of you guys are already on the Collators channel and already know Gil and I, but feel free to reach out. And yeah, hope to see you guys soon.
And I'm going to share here the links that didn't appear in the presentation, but that's our side of Collators in Moonbeam. And here is also our doc side if you want to look for more technical information.